Hello everyone, this topic is a little different. We have talked about a lot of services so far and we know all those services individually. In this small section, I'll tell you how do you create an architectural solution for a very simple application using all the services which you have learned so far. These are the services which you have seen. EC2, which is kind of a virtual machine on AWS data center. EBS, which is Elastic Block Store and is attached to the EC2 instances. VPC, which is AWS's network offering, will launch EC2 instances, create EBS volumes, etc. inside of VPCs, and then AZs and then subnets. Then load balancers, which are used to distribute load across multiple EC2 instances, but we should always use load balancer with auto scaling group so that scale out and scale in events happen automatically and load balancer distributes traffic to whatever instances running at that particular time. Then we have seen Route 53, which is AWS's DNS offering. How do you map a domain name with EC2 instances or to load balancers or to S3 static website or create complex routing? Then S3, which is AWS's online storage service. We have talked about a lot of S3 components in our S3 section. Finally, the last topic which we covered before this was EFS or Elastic File Store. We'll see a simple application deployment using 3-tier architecture. Let's say the application is an online video streaming website like Netflix. This application also stores user photos and images. What I'm showing here is a super oversimplified version of it. I mean, it cannot get simpler than this. We have VPC in North Virginia region, US East 1, then 3 AZs, let's say US East 1A, US East 1B and US East 1C. Each AZ has 2 subnets in them. These EC2 instances are the front-end instances which support the website. The website is running on these EC2 instances and provide user interface. Video upload and download by users are handled by these instances. These EC2 instances are in app tier and does some video encoding and transcoding, for example, using some programs which are running inside of these EC2 instances. Finally, these instances store some metadata or video rendering information. This can be thought of as a DB tier but without any databases. Alright, EBS volumes are attached to all the EC2 instances which will store data critical to running applications or programs on these EC2 instances. We have load balancer and auto scaling group in these places. Domain name is hosted on Route 53 which routes traffic to the load balancer. End users use domain name to connect to these EC2 instances which are receiving traffic from load balancer and via auto scaling group. S3 is used to store all the videos and images uploaded by the users. These videos and images are uploaded using applications sitting on these EC2 instances. Web tier instances communicate to the application tier instances via the second load balancer and auto scaling group to send some user information and metadata. These EC2 instances have programs running in them which fetch video files from S3 bucket and stores them back once the video transcoding is done. Finally, these EC2 instances talk to the EC2 instances in DB tier to send some data. These data are stored in EFS files by programs running in these EC2 instances. When users want to download or stream video files, applications or programs running on these EC2 instances fetch those from the other S3 bucket and renders them to the users. This is what our application does. Think of the complexity of this entire solution. Few more things. What if we lose the S3 bucket or EBS volumes attached to the EC2 instances, or for that matter, the entire EFS file system? If any one of these happens, we might get a severe hit on the entire application because all these are critical components. In that case, the entire product would be a flop because users do not expect any downtime whatsoever. I hope you know which direction I'm going. Think about it for some time by pausing this video. You guessed it right, disaster recovery. How do you create a DR solution of this entire application architecture? Let's analyze that first. We have critical data stored in S3 buckets. Then we have some useful information in EFS file system also, which is being accessed by multiple EC2 instances. EBS volumes, which are attached to all these EC2 instances, also store program critical data. The EC2 instances also have programs running in them, which are the backbone of the entire product or the entire application. So you have to make sure that programs in EC2 instances, S3 buckets, data in EBS volumes attached to the EC2 instances, and EFS file systems are not lost in case of disaster. What we can do is we can create a scaled down version of this entire application in the same or different region. Most probably you will create the DR solution in a different region. I'm saying again, this is an oversimplification. I just want to make sure that you understand how all services are used collectively as one. This is our DR VPC, maybe in the same region or a different region. We have scaled down version of everything else. These are our AZs and subnets along with load balancer and auto scaling groups. Okay then, let's see how do we replicate the entire environment above in the bottom section or in the DR site. For EC2 instances, create AMIs, copy them over to the other region and launch EC2 instances from there. Communication between these components would remain same as that of the primary site. Okay, what about EBS? Take snapshots from EBS volumes in the primary region, copy them over to the DR region and create volumes from them. For S3, we have very simple solution. Create a bucket in this region and enable cross-region replication. That's it. For EFS, we can use our own custom backup and restore solution or continuous backup solution. If you see now, this smaller version is exactly same as that of the primary version. The last piece is use Route 53 weighted round robin routing policy, and the DR side should have a weight of 0, whereas the primary side should have a weight of 100. So all traffic would only be sent to the primary site from the hosted zone. In case of disaster, this weight 100 and 0 can be reversed and traffic would be entirely sent to the DR side. We can also use a more simpler solution. Instead of using snapshot, AMI copy, etc., we can create a VPN connection between both the regions and use our custom way to replicate EBS data and application data on EC2 instances. Or for that matter, we can create a VPC peering connection too between these two regions or these two VPCs to achieve the same result. So this is the architecture I wanted to talk about. I tried to cover all the services which you have learned so far. I hope it was helpful. After this slide, I hope you have got a glimpse of how applications are created using AWS services. Things become more easier if you automate everything. You can do that using AWS CLI with shell scripting, Python scripting with AWS Boto library, or Terraform or Ansible. We'll anyway see Terraform and Ansible at the end of this course. Thanks for watching.